All right, this is a look at our polar review, part one. Um, so it actually is polar and conics. So here are the topics that you are going to need to study to be assessed on. So question one, we're going to identify each of the following if they are circle, ellipse, hyperbola, or parabola. So the first one's a definition, a set of points that are equidistant from a common point called the center. Well, that's a circle, right? All these points are equidistant from the center. This type of conic is formed by slicing a cone diagonally through its base. So if you were to slice a cone diagonally and you go through the base, right? Aren't you going to form a parabola on the side of the cone, right? An ellipse does not get sliced through the base, and a circle does not get sliced through the base. So if you're slicing through the base, you are either a parabola or a hyperbola, and a hyperbola requires two inverted cones, and you're slicing perpendicular through the base. What type of conic? It doesn't say that I have to put this in conic standard form, so I'm just noticing that there's a negative sign here in front of the y squared, so that tells me that this must be a hyperbola because I've got an x squared and a y squared, but one of them's negative. And then D, if I only have one of the terms being squared, then it must be a parabola. So just being able to identify the four types of conic sections. I didn't give you one for ellipse, but maybe on the next review I'll ask you about an ellipse. All right, so the next one, if it was a parabola on the test, if I gave it to you in this format, you should be able to graph it. Not necessarily complete the square to graph it, not necessarily use a bunch of information, but at least graph a parabola. And so if it's a y squared parabola, that's opening either left or right, right? Because it's not our friend x squared where it opens up or down. And our p-value over here is positive. So this is going to be a right-facing parabola. It has a vertex at -3, 2. So there's the vertex of my parabola. And the 4 p-value is 12, meaning that p by itself is just 3. And a parabola opens around a focal point and goes away from its directrix. So your p-value, you're going to go 1, 2, 3 units in front of the vertex this way, 1, 2, 3 units behind the vertex is your directrix. And remember, the total 4p distance is your focal width. So from your focus, if you go up 6 and dot a point, and down 6 and dot a point, that's the total focal width of your parabola. So just kind of the general method of graphing a parabola is as deep as I would go on parabolas on your skills test. All right, number 3 says use completing the square to just rearrange the general form equations. So once we get there, we don't have to do anything with it, just can you complete the square and transform the equation? So part A is almost there, right? I've got different coefficients, so I can't just divide by 4, but I could go ahead and kind of reverse, divide through by 36, so that I can see that this is an ellipse. So if it's equal to 1, it's an ellipse with a plus sign there, I should say. The center would be at 0, 0, and your major axis, your A value is 3, your minor axis is vertical, your B value is 2. All right, so in B, I've got a bunch of x squareds and y squareds over here, a bunch of xy terms over here. I think I'm just going to subtract everything to the left-hand side of the equation. So I would be adding x squared. I'm going to put it in order here. Add x squared, add 4x, and then subtract y squared to the other side, add 6y, and then I'm going to leave the -44 on this side of the equation. So all I've done so far is move this x squared, y squared to the other side, which made them opposites. This looks like a hyperbola, so I put the negative sign second in order. To complete this square, I would just add 4 to both sides. So let's think about here. To complete this square, I actually need to factor out the negative. So I have y squared minus 6y, right? Because if I factor out a negative from both terms, that's going to become negative. So I'm going to add 9 to complete the square. So what did I actually just do? I actually just subtracted 9 on this side of the equation. So I'm going to subtract 9 over here. So let's see, I get x plus 2 squared minus y minus 3 squared equals, how much is this? Negative, is it negative 49? Negative 44 plus 4 minus 9 is negative 49. All right, I need to get positive 1 on this side of the equation. So I'm going to divide through everything by negative 49. Well, that just made this positive. So I'm going to put this term actually in front. So I would have y minus 3 squared over 49 minus x plus 2 squared over 49, right? Because that negative sign is now here. These two negatives are positives, equals 1. So this is a hyperbola with a center at negative 2 comma 3. It's a vertical hyperbola because this is coming first, and I would do 7 as my a value and 7 as my b value. And it's not a circle because that's a minus sign, so it has to be a hyperbola. All right, so number 4, we're going to write an equation. So let's see, this is an ellipse. It's vertical, so my bigger value is going to go under my y. Let's see, the center is at negative 4 comma 4. So negative 4 comma 4, I'm going to do x plus 4 squared plus y minus 4 squared equals 1, right? That's negative 4 and then up 4. So now I just need to figure out my a and b values. So let's see, this had a distance of 1, 2, 3, and 3 squared is 9. And this had a distance of 1, 2, and 2 squared is 4. B is a hyperbola, and it's opening horizontally, so I can tell the x squared term is going to come first, right? Because the, what do we call that? The transverse axis for hyperbolas is horizontal. Looks like my center is at 2 comma 1. So I'm putting x first. So x minus 2 squared minus y minus 1 squared equals 1. How far did I go in the horizontal direction? From 2 to 8 would be 6 units. 6 squared is 36. And to my edge of my box, I went a total of 2 units, and 2 squared is 4. So there's my hyperbola formula. Let's see, write an equation for a circle or ellipse. So this is, I could give you pieces of information and you have to solve for the equation. So let's see, it's a circle and the center is at 4, 6. So I'm going to do that part first. X minus 4 squared plus y minus 6 squared equals, I need to figure out the distance of the radius, the r squared value. So if I do the distance formula, and I think about if I'm at 4 comma 6 and now I'm at over here 7 comma 10, my x values changed by 3 and my y values changed by 4, and the Pythagorean theorem, 3 squared plus 4 squared is 25, so the r value, the radius of my circle, would have been 5. In my equation I put r squared. Find the equation for an ellipse. So let's see, the end points of the major axis are at negative 4 comma 0 and positive 6 comma 0. So that puts my center at 1 comma 0, right? Halfway in between. And that makes my a value 5, right? So my a value is 5. It's a major axis horizontally. So I'm going to write what I have so far. X minus 1 squared plus y squared equals 1. And I know the a squared value would be 25. So one of its foci is at negative 3 comma 0. So that tells me that the distance for C is actually 4 units. And if I use my Pythagorean identity that a squared equals b squared plus c squared, I know that 25 is b squared plus 16. So that makes my b squared value 9. And let's see. So the last part of conics, my last conics objective, and then I'm going to pause the video and do a second video for the second half here. Just find the eccentricity of each ellipse. And remember, eccentricity is c divided by a. So for each of these equations, I need to find c. So 25 equals b squared plus c squared. So subtract 9 and square root it. So c would be 4, right? Because 16 is here, so square root it. C is 4, and a is 5, square root of 25. So 4/5 is an eccentricity of 0.8. And on this equation, let's see, a squared is 4, b squared plus c squared. Subtract 1 and take the square root. So this time c is the square root of 3. So I'm taking the square root of 3 and dividing by an a value of 2. So the square root of 3 divided by 2 is 0.87. So what is the shape of these ellipses? Both are very elliptical. And number 2 is slightly more elliptical, right? Because an eccentricity of 0.99 would be the most eccentric, ellipse that you could have. And an eccentricity close to 0, like 0.01, would be very circular.